Hello and welcome. My name is Mr. Asprey, the only maths YouTuber to finish in the top 200 worldwide in an FPL season, and this is EDEXCEL October 2020 Maths A-Level Pure Paper 2. Let's get into it. Question 1. The table below shows the corresponding values of x and y for y is equal to the square root of x over 1 plus x. And the values given to four significant figures. Use the Trapezium Rule with all the values of y in the table to find an estimate for the integral between 2.5 and 0.5. So we're going to use all those values there. So I'm going to start off by writing out the Trapezium Rule, which is that the area is equal to the height over 2. And then we have the y0 value plus two lots of the y1 plus y2 plus all the way up to yn minus 1, close brackets, and then plus one lot of yn. So what is the height? The height is the gap between each of these x values, which is 0.5. So we write that it's 0.5 over 2. And y0 is the first y term, which was 0.5774 plus two lots of the next terms, which was 0.7071 and 0.7746 and 0.8165, and then the final term was, which we only add on once, is 0.8452. Close brackets. And we put that into our calculator, and you have to trust me on this, just to save time, it's going to equal 1.5. Okay, question part 2. Use your answer to part A to deduce an estimate for the square root of 9x. So how do these differ? Well, this was 1x and this was 9x. So the difference between them is that this second one is multiplied by root 9, because that will then give me my square root of 9 times through. Okay, so what is root 9? Well, it's 3, so it's 3 lots of the original one, essentially. So therefore our overall answer for A will be 3 times the original value, which is 4.50. It says, given that the answer is actually 4.535, comment on the accuracy. Well, in order to comment on the accuracy, we need to find a percentage error. We do that by taking the difference between the two values. So this is the actual value, and we take away the estimate, which is 4.5, and then we divide that by the actual value, and then we multiply that by 100, and we get, I'll put that into my calculator just quickly. So that is 4.535 minus 4.5 divided by 4.535, and then we multiply that by 100 to get the percentage, and that is equal to 0.77%. So this is very accurate. Okay, so this is very accurate because it's obviously within a very small percentage. So I'll just write that this is a very accurate. Very accurate. Great. Question 2, we're looking at vectors. It says that P and Q have position vectors PQR. So PQR have position vectors PQR. Given that PQ and R lie on a straight line, so if it's tricky, draw a picky. Let's start with the origin, and let's imagine that P is here, and then Q is there, and then let's say R is there, and they do join up to make a straight line. Q is 1/3 of the way from P to R, so I could call this one segment, and this would be two segments, which will make the total 3, and P to Q is 1 out of 3, so 1/3 of the way along. So this is little p going in that direction, this is little q, and this is little r. Okay, so how can we find a expression for little q without essentially going from little q? So what we could do is, first off, actually we could find an expression for p to r. That's going to be very helpful. Yes, p to r is going to be very helpful, not including q. So to go from P to R, I can go backwards through P and then forwards through R. So this could be minus P plus R. Okay, that's helpful. And now how can I get from O to Q without going through Q? I can go from there to there, and I can go from there to there. Oops, sorry. Like this. So to get from O to Q, I can go through O to P, like such, plus P to Q. And therefore, an O to Q is little q, O to P is little p, and P to Q is 1/3 of P to R, which we said was minus P plus R. Okay, now we can just expand out. That should be a minus, sorry. Minus 1/3 P plus 1/3 R. And this is going to give us 2/3 P plus 1/3 R. And then in fact we could take a third out to get 1/3 2P plus R, which is I think what they asked for. Yes, it is. Okay, question 3, we've got that 2 log 4 minus x is equal to log x plus 8, and it says show that we get a quadratic from that. Okay, so we need to use our log rules here. This 2 coefficient can be raised over here and become the power of the input of the logarithm. So I could write that log 4 minus x squared is equal to log x plus 8. Now I've done that. Now I've got essentially log of something is equal to log of something else. So therefore, those two things, those two inputs, must be equal to one another. So I can say that 4 minus x all squared must equal 8 plus 8, so x plus 8. Expanding this bracket is going to give me 16 minus 4x plus x squared, and that's just going to be x plus 8. Simplifying, I'm going to get x squared here, minus 8x plus 16 equals x plus 8, and that's going to give me x squared minus 9x plus 16 is equal to 0. Oh no, sorry, I need to minus the 8, so plus 8 equals 0. Great, that's what we've asked for. State which roots is not a solution. Okay, well first off we need to find the roots, and we can do that by factorising. We can have x minus 1 and x minus 8 times together to give you positive 8, add together to make minus 9, so that is correct. And we can get x equals 1 and x equals 8. Okay, so and what we know about logs is if we have, for example, log of y, then y must be positive. Okay, whatever, you can't log a negative number. So at the moment, our two inputs are 4 minus x and x plus 8. So we know that 4 minus x must be greater than 0, and also x plus 8 must be greater than 0. Now, do they work for x equals 1? Well, this would give me 3 is greater than 0, which is good, and this would give me 9 is greater than 0, which is good. Okay, so x plus 1 works. Let's look at x equals 8. This would give me 4 minus 8 is minus 4 is greater than 0. Well, minus 4 is not greater than 0. So that doesn't work. So the question actually asks which root is not a solution, and you say that x equals 8 is not a solution as 4 minus 8 is less than 0. So 4 minus x is less than 0. Or 4 minus 8 is less than 0. Yeah, both work. Great. Binomial. Don't see these questions very often. This is year 1 binomial. I know it's year 1 because it's just a integer power and it's non-negative. So how exciting. How exciting. Let's have a look then. So we're looking for the x to the 4th coefficient. So I'm going to write 7c4 because I know the x to the 4th position coefficient will be in the 4th position, and I want this 2x to be to the power 4 to give me an x to the 4, and therefore a must be to the power 3 because these two numbers must add to make the power 7. And I'm told that that's equal to 15120 x to the 4. Okay, to the calculator we go. And we need to find our, sorry, just having a few technical issues here, bear with me. And we need to go to option on our calculator, and then we need to go to F6, and we need to go to prob, which is F3, and we need to find that NCR button. So we press 7, NCR 4, and this gives a value of 35. 2 to the power 4 is 16, and obviously x to the power 4 is x to the 4, and a cubed is just a cubed, and that's equal to 15120 x to the 4. The x to 4s can get rid of them, we don't need them, we're looking at the coefficients anyhow. And then I could do 35 multiplied by 16 to get 560 a cubed. That's equal to 15120. So therefore a cubed is equal to 15120 divided by the last answer. And that gives me 27. So a cubed equals 27. So a is equal to the cube root of 27, which is 3. Perfect. Oh, what's going on here? We've got two lovely curves here, and it's asked us to find the point at which they meet. So the x-coordinate of the point at which they meet. And it says the exact as well. So we have to we need to put our calculators away for this if it's exact. So when we want to find where two curves meet, if they're both equal to y, then we need to find the points where they're both equal to each other. So we set the two equations equal to each other as such. We've got 3 lots of 2 to the x, and this is the same as 2 to the 1 times 2 to the x, because when we have the bases the same and we multiply, we add the powers together. So that would give me 2 to the x plus 1. So, and 2 to the 1 is just 2, so it's 2 lots of 2 to the x. So that's 2 lots of 2 to the x. And if I add it to the other side, I've got 3 lots, and I'm going to add on 2 lots. So I've actually got 5 lots of 2 to the x equals 15. So therefore 2 to the x is equal to 15 over 5, which is 3. Okay, now we can take logarithms. So I can say log of 2 to the x is equal to log of 3. I can bring the x down to the front, like that. And then I can divide through. So I get log 3 over log 2. Or, actually, more simply, coming to think about it, we could just say that x is equal to, in base 2, 3. Because this is the same as saying that 2 to the x is equal to 3. Which is exactly what we've got. Right, I've got myself a polynomial which has been divided by a factor x plus 2. So we can put that into the polynomial divisor and see what comes out, and then that will give us the coefficients of a, b, and then the remainder will be c. So what I like to do is look at the lead term and the lead term of the divisor, and then divide one by the other. So how many x goes into x squared? Or just 1x. And then I multiply that down by the x and by the 2. So x times x is x squared, and x times 2 is 2x. And then we subtract. So x squareds will cancel, 8 minus 2 is 6, and we've got a minus 3 there. And then I look at the new lead term, which is 6x, and I ask how many x's go into 6x. Well, the answer is 6. And then I take that new term and I multiply down there and there to get 6x plus 12, and then I subtract, and that will give me minus 15, which is the remainder. So therefore, we can say that that ax plus b plus c over 2x is the same as x plus 6 minus 15 over x plus 2. So it asks me for the values of a. So a is 1 and b is 6 and c is minus 15. And now it's asking us to integrate between 6 and 0. So between 6 and 0, we have x plus 8 minus 15 over x plus 2 dx. Now, x, we would up the power and then divide by the new power. 6 is essentially 6 to the 0, up the power to 1, divide by the new power gives you 6x. And this one's a bit slightly trickier. We have to use our log rules here. So what I want is I want the numerator to be the derivative of the denominator. And the derivative of x plus 2 is just 1. So ideally I want 1 to be on the top. So I can take out a factor of 15, and that will give me this. And now that the numerator is the derivative of the denominator, then the integral of that is just ln of the denominator. But there are minus 15 of them, so it's minus 15 ln x plus 2 between 6 and 0. Substituting in 6 now is going to give me 36 over 2 plus 36 minus 15 ln 8. And then when we subtract 0, the x terms will be 0, and I will have minus 15 ln of 2. Now let's quickly just check. It wants it in terms of ln 2. Okay. Well, ln 8 is equal to ln 2 to the 3, which is equal to 3 ln 2 by bringing the 3 down. So I can write this as, 18 plus 36 is 54. And we've got 15 of these 3 ln 2's, so I've actually got 45 ln 2. And a minus makes a plus, so plus 15 ln 2. So in total I've got 54 54 minus 30 ln 2. And we're done. Question 7. We've got a curve and we've got a function, and you've got to differentiate it. Now, top tip: don't use the quotient rule. I just tried using the quotient rule, didn't go very well, ugly very quickly. Let's try and figure out a different way of doing it. Well, actually, I could write this part of my equation in a much simpler way, which is what I failed to spot first time I did this question. And we could write that 4x squared plus x over 2x to the half, and we've also got minus 4 ln x, can be split up. So we've got 4x squared over 2x to the, oh sorry, I don't know why I put minus a half there. It's just over half. Okay, and then we've got plus x over 2x to the half. Oh yes, that's much better. So 2 divided by 2 is 2, and x squared over x to the half, we subtract the powers, so we get 1.5, or to the 3 over 2. And here we're going to get a half, so it's 1 over 2, and we're going to get 1 divided by, x to the 1 divided by x to the half, so we should subtract the powers to get x to the half. Ah, much better, much better. Now we can just differentiate that directly, and we get 3x to the half. That's a quarter x to the minus a half, and ln x differentiates to 1 over x, so we've got 4 lots of 1 over x. Okay, now is that what they wanted? No, it is not. So we're going to have to do some rearranging here. They want the denominator to be 4 lots of x to the 3 over 2, essentially. Okay, so we've got 3x to the half, and this is the same as 1 over 4 x to the half on the bottom, and that's the same as 4 over x. And we could put this over 1 like that. And then we can make it a common denominator. So I can multiply this one, top and bottom, by 4x to the 3 over 2, which is the denominator we want. And that will give you 12, and the powers of x will add to give you squared. And then we're going to get plus, well, this one here needs to be multiplied top and bottom just by x. And that will give you x, and on the bottom it will give us the 4x to the 3 over 2, which is going to be our common denominator. And then this final one here, I would need to times the bottom by a 4 and an x to the half. So that will give me 16x to the half. And I think that is exactly what they required. Yes, it is. I will just tidy that up a little bit to write it in exactly the same form they have asked, which is minus 16 root x over 4 x root x. That's nasty. That's a nasty question, that. Next. it is a minimum turning point, so that is where dy by dx equals 0. Show the x coordinate is a solution to this. Okay, so we need to solve this equal to 0. So we need to solve 12x squared plus x minus 16x all over 4x root x is equal to 0. Well, whenever I have a fraction equal to 0, it's only the numerator that needs to equal 0. Because if the numerator equals 0, then the whole expression equals 0. The whole fraction does. And I want to I'm going to at some point need to divide through here root x by 12. I'm going to have to divide through by 12, and also I'm going to have to take the reciprocal of this power. So I'll show you what I mean. I want this to be x equals 4/3 minus root x over 12 to the power of 2/3. Well, if for example I have x squared equals 9, then in order for me to convert this into x equals, I need to take the reciprocal power on that side. So if I were to undo this, if I want to undo that, I could write 3/2 on that side, and that would be correct. Also, if I want to undo this, well, this 4/3 is a bit tricky, because if I was dividing by 12, then this would be actually 16/12. And now I'm starting to see where the sort of 16 comes from, which could be helpful, and where the divide by 12 comes from. And because we're dividing by 12, I notice this term is going to be the actual x, which I need to isolate. But ideally, I want it to be 3/2. So with all of that in mind, and also the 16 is just on its own, it's not multiplied by an x. So what I'm going to do is I'm going to divide through by root x. That's going to give me 12. Root x is x to the half, and dividing through will give me x to the 3/2. X divided by root x is just root x itself. And dividing through by root x is going to get rid of that root x there. Okay, next I can then isolate this by adding the 16 to that side, taking away the root x by moving that over. Dividing through by 12 is going to give me 16/12 minus root x over 12. And then finally, once again, if I want to remove a fractional power, then what I'll need to do is I'll need to take the reciprocal fraction on the other side. So this will become x equals 16/12 is 4/3, root x over 12, and that power will swap over to becoming 2/3 on that side. Okay. Next part. It says use the iterative formula of that particular formula we've created, where x1 equals 2. Find the value of x2, and then find the coordinate of x, the x coordinate of p to 5 decimal places. Okay. So this is all calculator work now. So I'm going to go to my calculator. The starting value was 2, so I press 2 equals. I then need to type in this formula, which is 4/3 minus root, and rather than putting x, I put answer, so that it uses 2 from the previous line. 12, close bracket, to the power of 2 thirds. I press equals, and that's my x2 value. So that's 1.13. 894 to 5 decimal places. And then I just keep pressing equals so that it converges upon the root. I can press it loads and loads of times until I get no repeats. Not repeats, sorry. So it stops changing. So it stopped changing there no matter how many times I press equals. So it's converged upon the root. So we can say that the root is x equals 1.15 650 to 5 decimal places. Perfect. Question number 8. We are given the derivative function. We're told the y-intercept. We're told that f of x plus 4 is a factor, so it says find f of x. Okay, so first thing I'm going to do, if I've got the derivative function, I can integrate that, and that will give me the value for y. So y is the integral of the derivative function, just in the same way that if you have an equation y equals f of x and you differentiate it, you get the derivative, or if you integrate it, you get back to the function. Up the power to 3, divide by the new power, gives me up the power to a 2, divide by the new power, gives me a over 2x squared, and up the power gives me to minus 23x, and of course plus c. Okay, now we know the y-intercept, so we can just write that the y-intercept is the c value which is added on. It's the value when all the x's go to 0, so that is minus 12. And finally we need to find a by using the fact that f of minus 4 will equal 0, because the factor theorem states that if x plus 4 is a factor, then f of minus 4 is equal to 0. So we say 0 is equal to 2 lots of minus 4 cubed plus a over 2 minus 4 squared minus 23 times minus 4 minus 12. This is going to be minus 128, and that is 16 over 2, which is 8. This is plus 92, and that is minus 12. So this is going to give us 80, so minus 48 plus 8a. And therefore 48 is equal to 8a, so a is equal to 6. Perfect. Okay, so it says find f of x. Okay, so f of x is 2x cubed. It's a over 2. You can see up here a over 2. We know that a is 6, so that must be 3x squared minus 23 x minus 12. Good job. Okay. A quantity, I thought I said quality, a quality ethanol. Now, a quantity of ethanol was heated until it reached boiling point. The temperature of ethanol, theta degrees at T, blah, 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 blah. Let's just get into it, shall we? There's your equation. And given that the initial temperature was 18, and after 10 seconds the temperature was that, find a complete equation for A and B. Okay, great. So initial temperature means T equals 0, and theta equals 18. So sub that in, gives me 18 is equal to A minus B e to the 0. So that is just 18 is equal to A minus B. Okay, and after 10 seconds, we've got t equals 10, and we've got 44 is equal to a minus b e to the minus 0.7. Okay, not ideal that, but nevertheless we can well, we can actually just go straight to our calculator really and go to menu, equation, simultaneous, and two unknowns, and we have 1a minus 1b. This is definitely the most efficient way of doing it, but I'm in it now, so we've got to carry on. And then we've got 1, and we've got minus e is it's right here, and we have got e to the minus 0.7, and that equals 44. Right, so we've got x, which is the first term, which is a, is equal to 69.6, and we've got b, which is the second term, which is equal to 51.6. Okay, it says find a complete equation, so you would not get the mark unless you actually write down them in an equation. So it's minus 51.6 e to the minus James Bond t. Great. So we've got the FNO is approximately 78 boiling point. Now it's never going to reach 78 because at the moment we've got 69.6, and that's actually the maximum, because all we're doing is we're taking away this blue part here, and that blue part can never be negative because we can never have an e value which is negative. So therefore we can say that the maximum temperature is equal to 69.6. So the model is not suitable. Is not suitable. Yeah, perfect. Okay. Question 10. We have that 3 cos A is equivalent to 4 cos cubed A minus 3 cos A. So we need to know the compound angle formula for cosine. So I could write that cosine 2 capital A plus 1a will equal cos of 2a multiplied by cos of a minus sine of 2a times by sine of a. So that's the compound angle formula for cosine. I can then use my my double angle formula for cosine, and I can replace, well, I want my answer to eventually arrive with lots of cosines in it, so I'm going to change the cosine 2a to 2 cosine squared a minus 1. And I'm going to multiply that by cosine a. And sine 2a is 2 cos a sine a. And that's also multiplied by sine a there. Okay, we can expand these brackets to get 2 cos cubed a minus cos a. And we can multiply these two signs together to get sine squared a. And we also know that sine squared is 1 minus cos squared. So I can replace the sine squared with 1 minus cos squared. Can expand those brackets out, and now I've got all of my terms in terms of cos. Terms in terms of cos. And we've also got a plus 2 cos cubed a. And then collecting the like terms, we've got 4 cos cubed a minus 3 cos a as required. Perfect. And next we need to solve. So let's see how we're going to use the identity. Well, we're going to replace this part of the identity with the blue part. So I can write for part B 1 minus, open brackets, 4 cos cubed x minus 3 cos x is equal to sine squared. Now, what do we know sine squared is equal to? It's equal to 1 minus cos squared, and expanding these brackets gives you 1 minus 4 cos cubed x plus 3 cos x is equal to 1 minus cos squared x. And then I can bring everything over to the right hand side so that my highest power of cos, which is the cubed, is positive. So bring that over to this side. I can keep this cos squared there. I can minus 3 cos. And I've got 1 on both sides, which can cancel. And that's equal to 0. And I can take out a factor of cos x to get 4 cos squared x minus cos x minus 3. And I'm hoping I can factorize that. And that will factorize into 4 cos x plus 3 and cos x minus 1. Just double check, does that work? 3 minus 4, yes, that is good. Okay, so where are my solutions going to be? They're going to be cos x equals 0. Here, cos x equals minus 3 over 4. And here, cos x equals 1. Okay, to the calc. Well, first off, what's the range? And it's in degrees. Yes, it is in degrees. So our range is from minus 90 to 180. Sorry, is that equal to as well? Yes, it is. So equal to. Okay, so let's look at, first off, cos to the minus 1 of, whoops, I should be in degree mode. Shift setup and change that to degree mode. And cos to the minus 1 of 0, well, of course we know that is going to equal 1. Sorry, 1. I mean 90. So we get x equals 90 is one solution. And then our next one would be cos to the minus 1 of minus 3 over 4, which is 0.5, and we get x is equal to 139 to the nearest degree, and cos to the minus 1 of 1, that one is 0. So we get x equal to 0. Now, are there any additional solutions? Well, in order to find the second solution, what I always do for cos, I would do 360 minus the first solution. So 360 minus this one would give me 270. 360 minus 139 would give me 221, and this would give me 300. Okay, so none of those are good enough, but we can subtract 360 from any of these ones to see if we can get something else within the range. Now, if I subtract 360 from this one, I get minus 90. So that one is also a valid solution. So my solutions are minus 90, 0, 90, and 139. Okay, next question. I'm asked, I've got a modulus function graph and it's drawn for me. That's lovely, thank you very much. Find the coordinates of P. So P is the minimum point. Now, how can I make this function as small as possible? Well, the modulus part of the function can only be positive. So if I want to minimize that, then I'm going to make it 0. And that modulus part is going to equal 0 when x is equal to minus 4. And when that modulus part is 0, then what does that equation become? It becomes y is equal to 2 times 0 minus 5. So there we have it. That is our minimum point, and that is the point minus 4, 5. Okay, next we've been asked to solve the equation 3x plus 40 is equal to 2 blah 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 blah. Okay, first thing I would do with a modulus is I would sketch it, because if you've got this calculator you might as well use it. And so the first one I would sketch would be 2, and then we would press the options button and go to numeric and absolute, and then we would have x plus 4, and then we would also have minus 5, and then over here we would have 3x plus 40. So sketch the two lines. I can't see the other one, so I'm going to zoom out a bit. Let's see what happens when I zoom out. I press. Okay, there we go, great. So it looks to me like that's only going to cross once, because the red line is steeper than the blue line, so it won't intersect again. So it's only going to cross once. Now we can find where it crosses, and this is a little bit of a cheat, but we can press G solve, and we can press intersection, and we know that that's going to be the answer, minus 10.6 and 8.2. But of course, we need to actually do the algebra. Now, also note that it crosses the blue line when the blue line has been flipped over. And what I mean by that is, this is the original graph 2x plus 8, essentially, or x, or 2 open brackets x plus 4, and the modulus part, the flip, is this bit. So that's the bit that's been flipped over, and that's the bit where it crosses. So in order for us to solve my equation, I would write 3x plus 40 is equal to 2 lots, or minus, 2 lots of x plus 4, because I'm looking at where the graph has been flipped, so I need to change the modulus part to a negative. So this is going to give me 3x plus 40 is equal to minus 2x minus 8 minus 5. That's going to give me 5x on that side. That's going to give me minus 13, and minus 40 is minus 53. So we're going to divide that through to get minus 53 over 5, which is minus 10.6, as our calculator told us it would be. Okay, next part. The line has the equation y equals ax, and given that the line intersects that at least once, find the range of possible values of a in set notation. Okay, this is quite challenging. We know that the line is going to be a straight line that's going to go through the origin. There's no intercept. So I'm going to model it by drawing it like this, and I'm going to have it just touch P once. And I'm going to try and figure out what that line is, because that's going to be a critical line, because the question asks us for it to cross at least once. So let's find out where it does cross exactly once. So this point P and the point O are 2 points on the graph. So I can do the change in the sorry, this should be minus. I'm not sure why that's not minus. I should do minus 5 minus 0 over minus 4 minus 0, and we get a gradient of 5 over 4, or 1.25. Okay, that's the gradient. Now, if I were to make the gradient any shallower, for example like that, then we're going to cross twice. And again, if I was to make it even more shallower, we would still cross twice. And in fact, if I was to keep rotating that line around, we're still going to cross twice. And now we're into the negative numbers now. Now that gradient is negative. And in fact, whenever the gradient is negative, we're definitely going to cross twice, even if it's a very negative number like that. Okay, we're going to cross at least once anyhow. So when the gradient is, when a is less than 1.25, we are definitely going to cross at least once, or maybe even twice. Now let's see what happens when the gradient is a bit more than 1.25. Then the line's going to come in like this, and that's not going to cross at all. And in fact, if we increase the gradient all the way up until 2, it's going to be parallel at 2. But if we go above 2, then it's going to cross once. So if A is above 2, then it will cross once again. So these are our two possible options. And we have to write that in set theory, set notation, sorry. So we write that A is either less than 1.25 or union A is greater than 2. Parametric integration, we need to know the formula, which is you integrate y multiplied by dx by dt, dt. Okay, so it's asking me to show that the area is this integral given the two parametric equations. So I'm going to start off by differentiating this, because that will give me dx by dt, which will be helpful. So let's do that. So I had that x was equal to 6 sine t, I believe. Yes, so dx by dt is going to equal 6 cos t. And we now need to write that formula down, which was the integral of y, and y was 5, let me just double check what y was, 5 sine 2t, multiplied by dx by dt, which is 6 cos t, and then that's dt. And what about the bounds? Well, this covers, the region covers the whole domain, and the domain of t is between 0 and pi over 2. So that's between pi over 2 and 0. Okay, so we are left with, you need to use a double angle formula for sine 2t. So we can write integral of pi over 2, 0, and we write 5 times by sine 2t is 2 cos t sine t, and that's multiplied by 6 cos t dt. So this gives us the integral between that and that. So 5, 2 and 6, that makes 30. We've got a cos squared there, and we've got a sine. And I think that is what is required. 60, oh sorry, that's 60, yeah. 2, 5 and 6, obviously 60. Cos squared sine t, yeah, same thing. Bosh. So use algebraic integration to find that the area is exactly 20. Okay, right, whenever you have a trig function like this, or any function to that effect, that's raised to a power and it's multiplied by its derivative, or at least a form of its derivative, then we can use the rule whereby we let y equal that yellow function raised up to the next power. So in this case, y equals cos cubed. We can then differentiate it and see how close we get to our original integral. So when I differentiate cos cubed, well, let me just write it here. I could write it as cos t cubed, and when I differentiate, the 3 comes to the front, the power drops, and we times by the derivative of the bracket. So we get 3 cos squared t. The derivative of cos is minus sine. Okay, so I'm going to end up with minus 3 cos squared t sine t. Okay, now that is relatively close to my original integral. In fact, what I would need to do is I would need to multiply by 20 in order for it to be the case. So if I were to times that by 20, I would get my, sorry, not 20, minus 20. If I were to times that by minus 20, I would get my 60 cos squared sine, what I'm looking for. So I'm going to actually multiply this by minus 20, and that will cancel out. So now I know that this integrates back up to that. So my final integral will be minus 20 cos cubed t between pi over 2 and 0. Okay, and now we can just sub in our values. So pi over 2 is 90, and cos of 90 is 0. So we're going to get 0 in our first bracket. And then we're going to sub in 0, and cos of 0 is 1, cubed is 1, times by minus 20 is just minus 20. And this gives me an overall answer of 20. Okay, next we have small dam, modelled, XY are in meters. The vertical wall of the is 4.2 as it says there, and then we've got to work out the horizontal walkways. We've got to work out this distance from there to there. So those are the two coordinates m and n where the y values are 4.2. And we've got a formula for y. It's 5t, so it's 5 sine 2t. So we've got to set that equal to 4.2 and find those t values that represent m and n. So m and n, very good wrapper, but also the 2 points we're trying to find today, and they are located when the y value is equal to 4.2 and the y value is 5 sine 2t. So dividing both sides by 5 gives us that sine 2t is equal to this. And then we're going to work out what 2t is by taking sine to the minus 1 of 4.2 over 5. So to the calculator we go. And we go to menu 1. And we go to shift sine. And we do 4.2, whoops. We do fraction 4.2 over 5, and we need this in radians, so I'm going to have to just quickly go to shift setup and go down and change this to radians, and we can press equals and we get 0.997, so 0.997, and then as soon as whenever you press shift to the minus 1 of sine, cos or tan, you've got to find the second equation, or the second solution, sorry. And we need to remember that sine is 2 pi minus whatever your value was, sorry, pi minus of course. Cos is 2 pi minus and tan is pi plus. So in this case I'm just going to go straight away and I'm going to press 2. No, not 2 pi, what am I thinking? Sorry. I'm going to press 1 pi minus that answer. And that's going to give me 2.144. So 2.144. Great, those are our two values, so we can find t by halving them. So I can halve this one, and I get 1.07. 1.072. And then I can halve the other one, and that would give me 0.498. And then finally, I need to work out the distance between them. So I need to find the x-coordinates. So I need to do 6 sine t to find the x-coordinates. So the x-coordinates, I would need to sub this into sine. So I need to sine the answer and times it by 2 to get 1.75. Sorry, not times it by 2, times it by 6. So the value was 6. My apologies. Times it by 6, it was 6 sine t, and that gives you 5.269. Great, so 5.269, and the other x value, that one came from that one, this one comes from this one, is going to be 6 sine of 0.498. And that's 2.866. And then finally the gap between them, so my length is the gap between them, so I would do one minus the other and get a gap of 2.4 meters. Brilliant. Okay, functions. Deduce the value of k. So k is a value which is excluded from the domain, and we know in maths we don't like to divide by 0, so I don't want my denominator to equal 0. So I don't want ln x to equal 2. So I don't want x to equal e to the 2. So therefore k is equal to e to the 2. Prove that this function, the derivative of the function is greater than 0. Oh no, here comes the quotient rule. So we write u is equal to 3 ln x minus 7, because that's the numerator, and we write v is equal to ln x minus 2. No one likes the quotient rule. The derivative of ln x is 1 over x, so that's going to give me 3 over x. The derivative of ln x is 1 over x, so that's just going to give me 1 over x. And now we can say that the derivative of g is v, always start with v, so ln x minus 2 multiplied by u dash, which is 3 over x, and then minus these two multiplied together, which is 3 ln x minus 7 multiplied by 1 over x. And that is all over v squared, which is ln of x minus 2 all squared. No one likes the quotient rule. Okay, we've got to show that that's greater than 0. First thing I'm going to do is I'm going to take out this factor here. So both of these terms on the top are multiplied by something over x. So I can move that x down to the denominator because all of the numerator has been divided by x, so that's the same as having an x on the denominator. So I can write ln of x minus 2 times by 3 minus 3 ln of x minus 7 in brackets, and I can bring that x down to the bottom to get ln of x minus 2 all squared. Okay, let's multiply out the top line. I get 3 ln of x minus 6, and here I get minus 3 ln of x plus 7. All over this. I can't be bothered to write the brackets around the x's anymore. Cancel, cancel. 1 on top. So 1 on top, and we have x, and then this squared term on the bottom. Okay. Now, okay, this is important. X has got to be greater than 0, which means that this is positive. We know that 1 is positive, and we also know that this is a square, so therefore that's positive as well. So we can say that as x is greater than 0, 1 is positive, and ln of x minus 2 squared is positive, g dash of x is positive. Find the range of a for which g of a is greater than 0. So this function here needs to be greater than 0. Okay, let's write that function out again down the bottom here. 3 ln of x minus 7 over ln of x minus 2, I believe. Is that right? That's right. But this time we are substituting in an a, so I need to replace those x's with a's. And we've been asked to state when is it greater than 0. Okay, when are you greater than 0? Well, that's a fraction. Now, a fraction is greater than 0 when the numerator is positive and the denominator is positive, or when the numerator is negative and the denominator is negative. Let's go for the positive approach first. So that would mean that 3 ln a minus 7 must be greater than 0, and ln a minus 2 must be greater than 0. So solving this gives me 3 ln a is greater than 7. So ln a is greater than 7 over 3. So a is greater than e over e to the 7/3. And just for some context, let's see what that value actually is. So it's roughly about 10. So a has got to be roughly about 10.3, let's say. Okay, but also we need the numerator to be positive as well. So this is going to give us ln a is greater than 2, so that a is greater than e to the 2. And for context, e to the 2 is about 7 and something. 7 point something something. I don't know exactly, so I can't bother to put in my calculator. So how can these both be true? How can a be greater than 7 and greater than 10? Well, it has to be just greater than 10. So a needs to be greater than e to the 7/3. So that's one solution. We also need to check whether it's negative and negative. Well, the only thing that's going to change here is making them negative. I'm just going to swap the signs over. They're going to be less than signs. So we'll end up with the same thing. We'll end up with a needs to be less than e to the 7/3, and a needs to be less than e squared. So in this case, in order for that to work, a would need to be less than e squared. So a would need to be less than 7 for it to be less than 7 and less than 10. So we have that a needs to be less than e squared. But also, as if this question hasn't given us enough, also we have to consider the fact that a must be positive. Because otherwise, if a is not positive, then ln of a negative, well, we can't do that, can't we? We can't do ln of a negative. So a must be positive. So we must also include that a must be can't be smaller than 0. And that is our answer for what is quite a challenging question for only 2 marks. Pick your battles. And talking of challenging questions, here's another one. A circle with radius r lies in the first quadrant, touches the x-axis and the y-axis. There's another line, 2x plus y equals 12. Show that the points of intersection satisfy this. Okay. First things first, if it's tricky, draw a picky. So that's exactly what I'm going to do. Lines, so it's only in the first quadrant and it touches the x and the y-axis, so it's going to look like this, like that, and the center of the circle will actually be the distance of the radius, so the center will be r. So the equation of this circle will be x minus r all squared plus y minus r all squared is equal to r squared. Now this we can rearrange to make y is equal to 12 minus 2x. And you notice that the equation we're trying to form only has x's in, so that's why I'm going to eliminate the y by substituting in this equation. I don't want to expand a triple bracket, so I'm actually going to expand this bracket first to get y squared minus 2yr plus r squared is equal to r squared. And these two can cancel while I'm there, might as well. And I will also, while I'm at it, expand this one. I don't know why I didn't do that first time, but anyway, so 2xr and then plus an r squared. And now I've got y squared here, which is going to be 12 minus 2x all squared. I'm taking away two lots of 12 minus 2x times r, and that equals 0. Okay, so I've got x squared minus 2xr plus r squared. Expanding this is going to give me 144. It's going to give me a minus 24x and another minus 24x, so a minus 48x. And it's going to give me a positive 2x squared. And expanding this is going to give me a minus 24r. And it's going to give me a positive 4xr. Okay, how many x squareds we got? We've got 5x squareds. How many x's have we got? We have minus 2r plus 4r is plus 2xr. We've also got minus 48x. And then the constants, we have an r squared. We have a minus 24r, and we have a plus 144. And that is pretty much what we need. Only thing we need to do is actually factorize this bit here, where I can take out an x to give me 2r minus 48, which is as required. Yes, fantastic, that is good. Okay, now it says, given also that L is a tangent to the circle, find the two possible values of R. Well, what do we know about tangents? We know that discriminant of any quadratic will be 0, because there will only be one intersection point, because a tangent will cut just at one point, so it has one intersection, so therefore the quadratic will give me only one solution. So the b squared minus 4ac must equal 0. Okay, here we go. What is the b? Well, the b is the number of x's, of which we have 2r minus 48. The a value is 5, it's 5x squared, and the c value is r squared minus 24r plus 144, and all of that equals 0. Okay, here we go. Let's expand this out. 4r squared, 2 times 48 is 96. And then 96 doubled is 192, so it's minus 192r, and I'm going to go to the calculator. I don't want to make a mistake now. 2 times 48 doubled, yes, very good, should have backed myself on that one. 48 squared though is plus 2304. And then we have 20r squared, so minus 20r squared. We have 20, or positive 20 times by 24 is 480. And then we have finally 144 multiplied by negative 20 is going to give me minus 2880. Okay, oh, I really hope I haven't made a mistake. Minus 16r squared. We've got 480 minus 192 is that. And then we have 2304 minus 2880. Which is minus 576. And does that divide by 16? Okay, that's good. So that would be minus 36. Now, does that one divide by 16? Yes, come on. 18r, and that divides by 16 to give you r squared. That's a minus though. Equals 0, so we get r squared minus 18r plus 36 equals 0. And I don't think that does factorize, so instead we will complete the square. and we will say that r minus 9 squared minus 9 squared, which is 81, plus 36 equals 0. So minus 9 squared minus 45 equals 0. So r minus 9 squared equals 45. Square root, we get r minus 9 is equal to plus minus the square root of 45, which is also equal to plus minus 3 root 5. Yep. Add the 9, we get r is equal to 9 plus minus 3 root 5. Beast question. Enjoyed that. And now we go on to question 15, where we have been asked to prove the geometric series ratio. So this is one you just got to know it, really. Unfortunately, you write that the sum of all of the terms would be the first term plus the first term multiplied by r plus the first term multiplied by r squared plus dot 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 all the way up to a multiplied by r n to the minus 1. The next step is we multiply that whole sequence by r. And this gives me a to the r, which I'll write here. And then multiplying again will give me a to the r squared, which I'll write there. And then we're going to go all the way to a to the r to the n minus 1. But the last term will be a to the r to the n, because we'll be adding on an additional r. So therefore the power will go up by 1. Then we subtract these two equations. And I'm going to subtract upwards, or am I? No, I'm just going to subtract them normally. So Sn minus Rsn will equal, well, all of these will cancel out. And we'll be left with a minus ar to the n. We can take out a factor of s to the n to get 1 minus r. And we could take out a factor of a to get 1 minus r to the n. And then we could divide through to get a 1 minus r to the n over 1 minus r as required. So easy 4 marks if you know how to do it. Very hard 4 marks if you don't know how to do it. We're given that s to the 10, S10 is 4 times S5. So S10 is equal to 4 multiplied by S5. Okay, well S10 is the, let's use the summation formula. We have a 1 minus r to the 10 over 1 minus r, and that's equal to 4 times a 1 minus r to the 5 over 1 minus r. Right, we can do a lot of cancelling here. Cancel the a's on both sides, divide through by a, times through by the denominators, they can go. So I'm left with 1 minus r to the 10 is equal to 4 lots of 1 minus r to the 5. And then we can expand that bracket. And then we can move it all over to the right side. So we have the highest power is positive. And we have this, and then minus 1 is going to give us 3. And that is a hidden quadratic, because we have, this would be r to the 0. And if ever we have r's or x's which go up in ascending powers like that, in an arithmetic sequence, then that is a hidden quadratic. So we can write here that r to the 5, and what two numbers times to get 3 and add to make minus 4, that's minus 1 and minus 3. which gives us r to the 5 equals 1 and r to the 5 equals 3, which gives us that r equals 1, or r is equal to the 5th root of 3. Now, always go back and check to see how many values of r they want, or it's a exact value of r. So no plural there. So let's go back here and see that r does not equal 1, so we can eliminate that from our solution set, and we can be happy that this is our only value of r. That is correct. Lovely. 16. Ooh, that's nasty. That's a nasty question, this one. Use algebra to prove that the square of any natural number is either a multiple of 3 or one more than a multiple of 3. Okay. First off, natural number are all the numbers, basically integers, but not including 0. And normally, for a question like this, it wouldn't be a bad idea to check to see what happens with the evens and what happens with the odds. That would be your natural approach to a question like this. So let's just try that. So if we were to go with evens, for example, we would say that n equals 2k, and we're looking here at the square. So we would take n squared, and that would give us 2k squared, and that would give me 4k squared. Now, unfortunately, I can't tell whether or not that is a multiple of 3, because it could be, or it could not be. You know, k could equal 1 when it's not, or k could equal, 3, and it would be a multiple of 3. So that's actually not the approach that you need to take. So rather than writing whether or not they're odd and even, we can write whether or not they are a multiple of 3. So we can start by going that n is equal to 3k, a multiple of 3, and see what happens there. And then after that, we can check, well, if it's not a multiple of 3, it could be a multiple of 3 plus 1. Or if it's not a multiple of 3 plus 1, then it could be a multiple of 3 plus 2. And those are the only options. So that covers all of the natural numbers. And let's see where we get with that. So n squared would equal 3k all squared. So n squared in this case would equal 9k squared. And that is obviously a multiple of 3, because we can say that's equal to 3 lots of 3k squared. So that's good. That shows that that is a multiple of 3. And now we can do the same here. Whoops, I meant to say that let's check that n squared is equal to 3k plus 1 squared. Multiplying out those brackets, we are going to get 9k squared plus a 3k and another 3k is a 6k and plus a 1. Now, taking out a factor of 3 from what I can do would give me this. So what is that? That's a multiple of 3, or it's one more than a multiple of 3. So give that a tick, because that is one more than a multiple of 3. Okay, let's test the final option. I'm just going to move it down a little bit here. N is equal to 3k plus 2, square both sides, and that's going to give me 3k squared. We're going to get a 6k and another 6k, so we're going to get a 12k, and we're going to get a 2 times 2, which is a 4. So we want to see if we can take out a factor of 3, so I can write that 4 as a 3 plus 1. And hopefully you can see here that this is going to be a multiple of 3 plus 1. So that is that's one more than a multiple of 3. Okay, now we need a concluding statement, and we can just, we could say QED here, but we can say that all 3 cases are as required. So therefore all natural numbers are. Perfect. I hope that was useful. Please subscribe and like, and I've got more A-level videos if you would care to watch them. That would be great. And share with any friends that are doing A-level maths or GCSE maths. Thanks a lot. Bye.